Motor rotates by providing electricity. They spin using the basic concepts of magnet. Opposite poles, north and south, attract each other, and the like poles, north-north or south-south, repel each other. Each cycle, the motor applies these principles using two magnetic fields. One remains stationary while the other rotates. The stationary part is called stator, and the other part called rotor or armature. Let's have a look on brushed DC motor structure and point out where are these two sources of magnetic field. First source of magnetic field results from the permanent magnet, represented by north and south pole, and that's the fixed source, the stator. And the second source of the magnetic field results from the wire carrying current. The magnetic field will be generated once the current is flowing onto the coil, and this coil is placed over the rotating part, which is the rotor. Then we have something called commutator. It's a split metal ring attached to the coil and placed over the rotor as well. And finally, we have brushes. These are carbon pieces that touch the commutator and supply electricity. Well, let's see how brushed DC motor spins then. When DC power is applied, current flows from the power source through the brushes, then into the commutator and finally into the coil. The rotor coil gets energized and creates a magnetic field in the coil, which interacts with the stator magnets, causing attraction and repulsion and making the rotor to rotate, so that its north and south pole align with the stator south and north pole respectively. In short words, the interaction between the rotor's magnetic field and the stator's magnetic field causes the motor to spin. However, once both magnetic fields are aligned, the rotor would naturally stop. Now we need another push. We need any change in magnetic fields in order to make the rotor spin again. So to do that, we need to reverse the polarity of the coil, so that the magnetic field of the coil is generated in the opposite direction and keep interacting with the permanent magnets. But how do we reverse the polarity then? That's where the commutator comes in. As the commutator rotates, it reverses the polarity of the current in the coil, causing a change in the direction of its magnetic field. As a result, the coil rotates to align with its new orientation. This explains why brushed motors need brushes, to maintain electrical contact with the commutator in order to reverse the polarity of the magnetic field each time the motor rotates 180 degrees, resulting in smooth and continuous rotation. However, brushes wear out over time, leading to maintenance and efficiency loss, which is why brushless DC motors eliminate them completely.